In the last presentation, we completed the half subtractor. Now in this one, we'll try to find out the logical expression for the full subtractor. On the right hand side of the screen, you can see a white box, which is our full subtractor, and we don't know what is inside this box, and this is something we have to find out in this presentation. Now there are three inputs to this full subtractor that you can see, A, B and C, and two outputs, D and B, O, where D is your difference, okay, and B, O is your output borrow. Okay, now in this three inputs, A is the number in which you want to subtract the number B, and C is your borrow from next stage. Okay, C is the borrow from your next stage. Now the prime goal of this presentation is to find out the combination of the gates which makes your full subtractor. So as we are having the three inputs, we are having the 8 possible combinations that I have already written here on the left hand side of the screen. Now we will try to perform the subtraction within these three inputs and try to get the difference and the borrow output. And the concept that we are going to use for the subtraction is very similar half subtractor. So 0 minus 0 is your 0. Okay, 0 minus 0 gives you 0, and again 0 minus 0 gives you 0. So there is no borrow involved, and also the difference is 0. So 0 and 0. Similarly, 0 minus 0 gives you 0, and 0 minus 1. You want to subtract 1 from 0, so you are definitely going to require the borrow. So the borrow will be 1. And now as it took, this 0 took borrow, so it will become 2 instead of 0, and 2 minus 1 gives you the difference equal to 1. Fine. Now again 0 minus 1, the same concept will be here. 0 minus 1, the 0 is going to require the borrow, so borrow is 1, and as it took borrow, it will become 2, so 2, it will become 2, so 2 minus 1 gives you what? 1, so difference is 1 in this case. Now again 0 minus 1, so 0 minus 1 is what? It is 1, okay, that we saw in these two cases. And 1 minus 1 is what? 0. And as this 0 took the borrow will be 1. It's very simple to do. 1 minus 0 is 1, and 1 minus 0 is what? 1. So 1 is the difference, and you can see that there is no borrow involved, so the borrow will be 0. 1 minus 0 is again 1, and 1 minus 1 is what? 0, and there is no borrow, so difference is 0 as well as the borrow is 0. 1 minus 1 is 0, and 0 minus 0 is 0, so again both the difference and borrow is 0. 1 minus 1 is 0, and 0 minus 1, again a borrow will be involved to make this 0 2, so borrow is here, and 2 minus 1 is 1. So this is what we are having after doing this subtraction, which was a real quick one, hoping that you know how to subtract the two binary numbers. If you don't know, then go to the playlist and see the lecture in which we discuss the binary subtraction. So the difference is 0 1 1 0 1 0 0 1, whereas the borrow is 0 1 1 1 0 0 0 1. Now we are going to minimize this function D and BO by using the Carnot map. So as you already know, in the Carnot map, we are having the cells equal to the number of what? Number of possible combinations. So let's make the 8 cell K map. We also call it a 3 variable K map, and we are having the inputs A, B, C, where A is the MSB, C is the LSB. So A will be here, B, C is here. 0 0 0 1 1 1 1 0 0 1. We are going to require the same K map to solve for BO, so I'm going to copy it and paste it so that we will use the same K map, 8 cell K map for B output. It will save our time a bit. So this K map is for the difference Now let's fill this K map 0 1 1 0. So this is 0 1 1 0. Then we are having 1 0 0 1. So 1 0 0 1. Again we are having a interesting filling in this K map, which is each and every one is single. We cannot make the group of these ones. You can see that. And whenever this type of case appear in your K map, we call it a checkboard configuration. And whenever you are having a checkboard configuration, the difference is directly written as the XOR combination of the inputs, which means that D is equal to A XOR B XOR C. It is very important thing. This is very important. You have to remember this in your papers. So this is what we discovered, the checkboard configuration, and this configuration appeared in our full adder, and also this configuration appeared in our parity generator. Okay, and in parity generator lecture I proved that these combinations of single ones is going to give you A XOR B XOR C. So we are not going to do it again. If you are having any doubt regarding this, go to the parity generator lecture and find it out. Now it's time to make the K map, or you can say that the fill the K map for your output borrow, and it is 0 1 1 1. So we are having 0 1 1 1 and 0 0 0 1. So 0 0 0 1. So let's make the grouping in this. The first group I will make is of these two ones, the next one is for these two ones, and the last one is this one and this one. So the borrow output is what? For this first group we are having BC BC. For this group we are having A complement, and B is changing from 0 to 1, so it is 1, and C is 1, so A complement C. Similarly for this group we are having A complement, and C is changing from 1 to 0, so it will be 1, and B is 1, so B. So this is what we are having as the borrow output, and